Let's see if we can do number 33 together really quickly. I'm going to move sine to the opposite side. We only have so much time left. That's why I'm quitting into uber fast mode right now. And then I'm going to square both sides. So I'm going to write this down twice. 2 cosine of x, 2 cosine of x, 1 minus the sine of x, 1 minus the sine of x. So when I multiply, I get 4 cosine squared x. I'm going to FOIL this out: front, inside, outside, and last. Now, in these problems, 29 through 33, I know that the pattern is to use factoring as a way to solve. So I'm going to switch this right now to 1 minus the sine squared x. I know that's equivalent to cosine. And there's 2 sines of x's here. And then I'm going to be lazy right now. I'm going to distribute the 4 to get 4 minus 4 sine squared x. And I'm going to be lazy in terms of, I'm going to move this to the opposite side by subtracting. I'm going to move this to the opposite side by adding it. Does that make sense to you guys in back so far? So I have nothing left on the left-hand side. And when I combine like terms, 1 sine squared and 4 sine squared is 5 sine squared. So 5 sine squared minus 2 sine of x minus 3. And I want to see, is it possible that I go through and I factor here? Well, let's first let u equal the sine of x. So this is 5u squared minus 2u minus 3. Can I think of 2 things that multiply to equal negative 15 and combine to give us negative 2? Negative 5 and positive 3. I'll use your AC plus B method. Now, in this position, I'm going to put down my 2 others, which would be negative 5u and positive 3u. So I have 5u, u minus 1, u, and I do the u minus 1. What times u equals a positive 3u? Okay, all that's good. Now I have u minus 1 and 5u plus 3. We're still good at back so far? I'm going to replace the u. U is equal to the sine of x, so I really have the sine of x minus 1 and 5 sine of x plus 3. Okay, I'm going to set each one of these quantities right now, set it equal to 0 and solve. So I have sine of x minus 1 equals 0 and 5 sine of x plus 3 equals 0. So I want to know where's the sine of x equal to 1 and where's the sine of x equal to negative 3/5. Okay, so the sine of x, by the way, notice that we're doing 1 revolution and it's in terms of degrees. So where's the sine equal to 1? That's like your y. It's way up here at 90 degrees. So tentatively, I think one answer is 90 degrees. Then I'm going to grab a calculator. Grabbing a calculator here. And let's do this other one. So I'm going to put it back in 2 degrees. Please take your calculators if you're in class. I'm filming. Put them off to the side, please. And I'm going to do an inverse sine, make sure you're in degrees, of negative 3/5. And I come up with a negative, 36.86. What does that mean? That means from here we're going to drop down. So if I take 360 and I add it to that previous value, I get right here, 323.13. So I think tentatively 323.13. Okay, that's one place. Now a negative sign could also be right here. So I want to drop down here a distance of 38. So 180 plus 38.869. So I think that these 2 values tentatively right now, 216.86, these 2 values, why? Because they both have a sign value. They both have a sign value. 2 places where the sign is negative. I dropped down from 180 and from 360. So now it's time to go back and check those. So I have 3 things to check. Let's go back to this very original equation here, which is right here. And let's plug it in. So let's go 2. I'm going to start with 90 degrees. 2 cosine of 90 plus the sine of 90. And I want this to equal 1. It does equal 1. That tells me that this is not only tentatively an answer, it is officially an answer. Let's try the next 2. Can I do 2 cosine of 323.13? And I want to add plus the sine of 323. So I'm checking right now for extraneous solutions. Okay, that is pretty much 1. Why is it not exact? Because I had to round here. So I'm checking my very last one for an extraneous solution, and I'm going to go 2 cosine of 216.86 plus the sine of 216.86. Let's see if this equals 1. It does not equal 1. That means it's extraneous. I only have 2 solutions to consider for number 33.
Good job.